With weak acids and weak bases, the reverse reaction can happen a lot. So what that means is not only can they act as acids and bases when they're in their normal form, but they can act as an acid or a base if it's just the associated ion available in the solution. Let's look at this with an example, and I think it'll be clear. So if we have HF, it'll react to form H3O plus and F minus. But what's important about this is that F minus is strong enough to steal that proton back and go backwards. So if the HF hadn't existed in the first place, a acid-base reaction would still happen when the reverse reaction happened, and F minus, which is the ion associated with a weak acid, would act as a weak base. Again, if it passes it this way, it's giving up the hydrogen to form hydronium, and that's a weak acid. But if the reverse reaction is possible, F minus itself can act as a weak base, performing the reverse reaction and taking that hydrogen back. Let's look at the salt sodium fluoride. If sodium fluoride is added to water, it will dissolve into sodium and fluorine ions. The sodium ions like to stay in solution, so they will not react with the water to form NaOH and H3O plus. You'd need two waters to make that happen. That doesn't happen because sodium is the conjugate of a strong base. That means if you put sodium hydroxide in water, it all dissociates to form sodium and hydroxide, and so the reverse reaction doesn't happen. So what I'm talking about in this video doesn't happen with the conjugates of strong things. It only happens with the conjugates of weak things, which brings us to our fluorine. Fluorine, on the other hand, is a conjugate of a weak acid. I'm going to do this example a little bit lower. Is a conjugate of a weak acid, HF. What that means is the reverse reaction is possible. So if I put fluorine into solution in some other method, that F minus is available to react with water to produce HF and OH minus. This equilibrium would exist where the HF would then donate back and go to H2O. But what's important here is this F minus in this salt that appeared to have no acid or base properties itself is able to act as a base because it's the conjugate of something that's weak, and as a result it's able to produce hydroxide. Let's look at NH4Cl. Again, I don't see any direct acids or bases in this, but I can imagine of both of the ions that make up this salt as conjugates to two different acids or bases respectively. Cl, for example, is the conjugate or the ion associated with the acid HCl. Because HCl is a strong acid, that means that if it sees water, it reacts to produce H3O plus and Cl minus. And because it's strong, there is no reverse reaction. So what that means then is if Cl minus is introduced into water on its own, it is not able to do the reverse reaction and act as a base. Alternatively, ammonia is the ion associated with the weak base, ammonia. If ammonia was placed into water, it would react with H2O to produce NH4 plus and OH minus. But what's important about this is because it's a weak process, the reverse reaction does occur. So what that means then is that this NH4 is able to drive this reaction backwards. So if that NH4 finds a water molecule, it can react to produce NH3 and donate its proton, creating hydronium, where it's acting as a weak acid. So we took this original compound, which had no clear acid or base properties, and we used it to determine that if we put this in, because this can act as a weak acid and this doesn't act at all as a base, this will actually act as a weak acid. We call these acid salts or base salts because they're just a salt. It doesn't appear like they should be an acid or a base, but their ions actually have acid or base properties based on reverse reactions associated with weak acids or weak bases. We do not consider these when we have the conjugate of two things that represent strong acids and strong bases. We do not need to consider the conjugates of strong acids and strong bases because the reverse reactions are not important and so they do not occur. So that's how we can take a salt and find out if it behaves as an acid or a base.